Hey SM3, this is 10.6. Technically it's not the 10.6 from your book. We call it 10.6 even though what we're going to cover isn't in your book. I don't have a slide presentation. This is actually your notes. So hopefully you either picked up notes from class or you printed them off. They're on Canvas. I am just going to go through the notes. So if you don't have those notes, make sure that you have those. Or I guess you could just take your own notes, but it would be easier if you had them. All right, so we'll just start filling in those notes. So we're going to talk about confidence intervals. Confidence intervals are an estimate of, hang on one second, an estimate of a population parameter stated as a range with a specified degree of certainty. Okay, so in other words, what it is I can say, I am 90% sure that what I'm looking for is between here and here. Or I'm 95% sure that what I'm looking for is between here and here. Okay, so that's what we're looking at. So we have here this right here, the maximum area, or the maximum error of estimate is a formula, E equals Z times S over the square root of N. Now in this case, Z is not the same thing as your Z score. It is called the Z value, and it is a constant. It's just a number, okay? S is your standard deviation. I'm not sure why they didn't use sigma, but they're calling it S. And N is your sample size, like it always is. Now your confidence intervals, which is what we've been talking about, what we're talking about up here, I'm going to call it CI, is your sample mean plus or minus this maximum error of estimate up here. So if you want to actually write out the whole thing as one formula, it would be X bar plus or minus, in parentheses, Z, your Z value, times S over root N, close parenthesis. Okay? The three most common intervals are 90%, the Z value is 1.645, 95%, 1.96, and 99%, 2.576. As an example, a sample of 400 adults were asked the average time spent watching television each weeknight. The mean time was 68.4 minutes. That's your X bar. So 68.4 minutes. And I should have put in here N is 400. Okay, that's the number of adults. With a standard deviation of 20.9 minutes. And I want a 95% confidence interval. So Z, if I come back up here, 95% confidence interval, Z is 1.96. Okay? So I'm going to put this into my formula, which is X bar plus or minus Z times S over root N. So 68.4 plus or minus 1.96 times 20.9 over the square root of 400. Now, I can't put this whole thing in my calculator because I have a plus or minus right here. So I'm just going to put this in my calculator, and I end up with 68.4 plus or minus, let's see, 2.0482. So we are 95% confident that the population mean, we started with a sample mean, that's what this is, that the population mean is between 66.35 and 70.45. So we can get an exact mean with a sample, but the population mean, we got to give it a little wiggle room, right? Because we don't know the whole population mean. That would be, nearly impossible to get. Okay, so we got to give ourselves some wiggle room, kind of like with the margin of error. Okay, so let's look at this. Find a 99% confidence interval for each of the following. So this, it's not even a story problem, they just flat out tell us. And 99% interval is 2.576. So 2.576. So we're just gonna do these couple. All right, so we have, again, confidence interval equals x bar plus or minus z times s over root n. So this equals 78 plus or minus z, which is 2.576, times s over the square root of 150. So this turns out to be 78 plus or minus 1.935. And if I want to put it in interval form, okay, let's see, 78 minus 1.935 is 76.065, and that's going to be plus or minus mu. Remember that mu is the population mean. And we're talking about the population has the wiggle room, okay? The population mean. And then give or take 78 plus 1.935, which is 79.935. So technically this would be the correct interval form, okay? So then this one, we would have 19.3 plus or minus 2.576, that's my z, times s over the square root of n. And that becomes 19.3 plus or minus 0.5865. And that is 18.71 plus or minus mu plus or minus 19.89. Okay, so people have been asking me, what do I round to? What I like to do, I like to keep things unrounded, I guess, unless it goes on for 8 decimal points or something. I keep it at about 4 or unrounded until the very, very end. And then I round it to 2 or 3 decimal points. Okay, all right, for the sake of time, we're not gonna do this one. And I think what we'll do is, I've got some try thises. Well, I have a try this, and we will do that in the next video.